Uh, we are here with a new class on differentiation. And so this class is about the things. Now, the question here we are doing is the differentiation. We have already done the things about the product rule and the quotient rule in the differentiation. Now we are proceeding towards the chain rule. This is another aspect of differentiation. This is the chain rule. This is chain rule. Okay. Now, what is the meaning of chain rule and how you will proceed with the questions regarding the chain rule? So, there is a question which is saying this thing, that you have to differentiate cos x squared plus 7x. This is the question. Now here in this question, this is question number 1. Now here in this question, what you can do is you have to first differentiate in accordance with the cos. Okay. Now we know that there is a parent form. Parent form is cos x. Sorry. We know that if you differentiate dy dx of cos x, it will give you minus sin x. Okay. And what it means here is that you are having cos x squared plus 7x. You make it the cos x as a parent function, and you will be having minus sin x on differentiating cos x. Now here, assume that this to be the x, but you will be having minus sine x squared plus 7x. This is the same. But the thing here is that x squared plus 7x is not x. It is not x. It is actually x squared plus 7x. Therefore, what you have to do is you have to differentiate this again. This is dy dx of x squared plus 7x. Now, what will happen? What will happen? If you differentiate it, you will be having minus sine x squared plus 7x times, if you differentiate x squared, it will give you 2x. And if you differentiate 7x, it will give you 7. You have to differentiate these both terms, x squared and 7x. Now your answer will be how much? Your answer will be 2x plus 7. And the minus will remain here, and this is sine x squared plus 7x. Okay? Fine. Let's do some more questions. Question number 2 is there. For example, if you are having d by dx of sine square x. This is sine square x. Okay. What it means? It means that you are having like this dy dx of sine x and whole square. Just like this. Sine square x means sine x whole square. Now assume that sine x is not sine x, it is x. Now you have to differentiate x squared. What it means? X squared is a parent function. Now, as we go for x squared, it gives us 2x on differentiating x squared. But here we will get 2 sine x. Okay. But again, sine x is not actually x. Therefore, what we have to do? We have to now differentiate this sine x, which is like this dy dx of sine x. Okay. Now, when you differentiate dy dx of sine x, you will be having 2 sine x, and this is cos x. Further, we know that this is a formula, and this formula is sine 2x. We know that sine 2 theta is equals to 2 sine theta cos theta. Okay. Now, let's start with one more. For example, you are having d by dx of square root of sine 5x cubed. See, question is very interesting. We have to differentiate three things, one by one. First, we have to go with the outermost part. And here the outermost part is under root x. The parent form is d by dx of root x. And it is equals to how much? It is equals to 1 over 2 root x. You know it very well. I have earlier told you in the previous section. What it means, the d by dx of under root x is equals to 1 over 2 root x. We assume that sine 5x cubed is x. Therefore, under root sine 5x cubed is equals to 1 over 2 under root sine 5x cubed. Okay, there is no doubt in this part. Now, how much it will be? It will be equals to 1 over 2 under root sine 5x cubed. Fine. But sine 5x cubed is not an x. Therefore, we have to differentiate it. Okay. Now, here this is sine d by dx of sine 5x cubed. Now, we can assume 5x cubed to be x. And we are having a period function as sine x. And we know if we differentiate sine x, if we differentiate sine x, we will be having cos x. What it means that this thing will remain as it is. The whole of the thing will be here, 1 over 2 root sine 5x cubed. And now here, sine will be converted to cos. This is cos 5x cubed. Now, the last thing is 5x cubed, because this is not x, this is 5x cubed. We have to differentiate it. And while differentiating it, we will do like this, d by dx of 5x cubed. Then the whole of the answer will be first 1 over 2 under root sine. Sine 5x cubed times, this is cos 5x cubed. And this is, if we differentiate it, I will be having 15x squared. The whole of the answer is like this. This is the whole part which you will be getting. Clear? We shall proceed further. This is question number 4. Let's do some more questions. Some interesting questions are here. Okay. If we are having the function like this, tan log sine inverse x. Okay, just stop here. I'm not going too lengthy. 10 log x. Okay, this is a function. Now here, the parent function is what? 10x. We are having the parent function as 10x. This is d by dx of 10x. We will be having it as equals to sec square x. Now here it will become sec square log x. But actually, this is not x. It is a log x. And we have to differentiate the log x again. It will be like this, d by dx of log x. Now, it will be equals to sec square log x. And if we differentiate log x, we will be having 1 over x. So, your answer will be sec square log x all over x. Clear? Clear? Okay, fine. Now, going to the next question. If we are having a question, for example, there is a question which says you are having log x plus under root x squared plus 1. This is a question. Now you have to differentiate this question. And you are having d by dx. Okay. Now here in this question, the parent function is log x. We say that d by dx of log x is equals to 1 over x. Now here, what will happen? We will be having 1 over x. This whole is to be put in the denominator of 1. We will be having 1 over x plus under root x squared plus 1. Now what we have to do further? We have to differentiate this whole part again. Therefore, dy dx of x plus under root x squared plus 1. What will there be? There will be 1 over x plus under root x squared plus 1. And here I will be having, if you differentiate x, you will be having 1 over x. Oh, sorry. If you are now here, what you have to do is you have to differentiate this. This is the x here. And if you differentiate x here, you will be having 1. And if you are to differentiate under root x squared plus 1, you will be having 1 over twice under root x squared plus 1. Now, what this will be? If we differentiate this and we are having 1 over twice under root x squared plus 1, we have to differentiate x squared plus 1 now. Okay, the same thing, the question which we have done of the square root. First, we have to differentiate the part square root, the power sign, and then we have to differentiate the things which are inside the square root, which is x squared plus 1 here in this case. Okay, now this whole thing will remain as it is. It will be 1 over x plus under root x squared plus 1. And here, if we differentiate it, this will be like this, 1 over twice under root x squared plus 1. And here, x squared will give you 2x and plus 1 will give you 0. There is no need to differentiate 1 or write down the 0. Now here, what we have to do? We have to cancel this 2 and 2 from here, both the sides. Okay. And after canceling out these two things, we have to solve this. I have to erase some part of this question. I'm just erasing from the top. Just wait. Okay. Now I'm differentiating this and I'm solving it. In the first part, I'm having 1 over x plus under root x squared plus 1. And in the second part, I have to do the LCM. This will go to multiply with this. This will give you under root x squared plus 1. And here this is plus x. And in the denominator, you will be having under root x squared plus 1. Okay. Now what I can do is I can just cancel out these two things. This will give you 1. And the numerator 1 in the denominator. And you will be having your answer as 1 over under root x squared plus 1. This is the required answer. Okay. Now we will move on to the next question. This is question number 6. Question number 6 is what? Now let's do the question number 6. And let's take another question. And this question number 6, what you have to do is you have to just do some of the parts. Let's go with another question. Let's say that you have to differentiate e power under root 10x. Just say that you have to differentiate e raised to power under root 10x. This is the question which you have to do. Okay. Now, how and what you will do? The parent function is d by dx of e. This is the parent function. And in this parent function, you will be having e power x. Okay. Same thing if I go here, you are having e raised to power under root 10x. Now, if I assume under root 10x to be x in this form, then I will be having e raised to power under root 10x. But actually, this is not under root x. This is not x. This is under root 10x. And what I have to do? I have to differentiate this again, which is under root 10x. Now, what will be there? I will be having e raised to power under root 10x. And there, if I have to differentiate this part, which is under root 10x, first I have to differentiate the square root, because 10x is inside the square root. Now, we know that d by dx of 10x of under root x is equals to 1 over 2 root x. Okay? And if you are unable to do these things like under root x or anything else, you can go and click the I button, and you will be having all the lists, all the videos, and you can easily go and check the videos which you are interested to check it. Okay, go and click the I button. Now here, this is what under root 10x, it will give you 1 over 2 root 10x. Okay, this is, but again, this is not x, this is 10x. Therefore, now what we have to do is we have to differentiate 10x. Okay, it means you have to differentiate one by one. First outer, then inner, then most inner, then most inner. And this way you have to do. Now your answer will be how much? You will be having your answer as e root 10x. And the denominator you are having 10 2 root 10x. And this is 10x, and which on the squaring we will be having 6 square x. Okay, this is the answer of the question. Let's do another question. You are having a question like this: log 10 pi by 4 plus x. Now you have to differentiate. First thing, you have to differentiate the log. Second thing, you have to differentiate the tan. And third thing, you have to differentiate pi by 4 plus x. 3 things you have to differentiate, mind it. First, differentiate log. Second, differentiate tan. And third, differentiate pi by 4 plus x. Now here, when you differentiate this, what you will be having? The parent function is log x. Now here, if you are having d by dx of log x, it will give you 1 over x. Okay, now it means that you will be having 1 over 10 pi by 4 plus x. This is the first thing which you have to do. This is a differentiation of log x. Now, you have to differentiate the tan x. Just put the sign of dy dx, write it tan pi by 4 plus x. Now, the parent function is tan x. Now, we know that dy dx of tan x is equals to sec square x. Okay. Now, how it will be continued? 1 over 10 pi by 4 plus x times sec square pi by 4 plus x. Okay. One thing is here is it could be more beneficial if you put x by 2. Okay. This is much better. You will get a direct formula in the last. Now, if you are having sec square pi by 4 plus x by 2, this is the part, and now you have to differentiate this third part, which is d by dx of pi over 4 plus x over 2. This is the third part. Okay. Now, in the third part, what you can do here is you have to first, what we have to do is we have to just to remove all these things which are earlier on the board, so that we are having a good quality of paper, the board on that. The space is there now, can easily solve the things. Okay. Now, that's the question. Now we are differentiating it, and differentiating it, what we are having this sec square x, and this is 10. What is the formula for tan theta? We know that tan theta is equals to sine theta over cos theta. Okay, and if I write down this here for this, then cos theta will go on the upper side. We will be having cos pi over 4 plus x over 2, and in the denominator I will be having sine pi over 4 plus x over 2. Furthermore, for sec square pi by 4 plus x over 2, what is sec theta? Sec theta is equals to 1 over cos theta. What it means that I will be having 1 over cos square pi by 4 plus x by 2. Now there is a third thing. What's this third thing? Third thing is pi by 4 plus x by 2. So pi by 4 is 0, and for x over 2, it is 1. Okay, This is 1 over 2. Now we can cancel out this cos one time from here. Now I'm having the denominator. This is 2, this is sine theta, and this is cos theta. We know the formula for 2 sine theta cos theta, and the formula is equals to sine 2 theta. Okay, now it will give me what? It will give me 1 over sine 2 theta, which is sine 2, and theta is how much? This is pi by 4 plus x over 2. If I could multiply this 2 inside both of these terms, I will be having 1 over sine twice pi by 4 plus twice x by 2. This 2 and 2 will cancel out. This will cancel out. Now, this is sine pi by 2 plus x. And how much is the value of sine pi by 2 plus x? How much is the value of sine pi by 2 plus x? Okay, just wait, just wait, just wait. Sine pi by 2 plus x. We know that sine 90 plus theta is equals to cos theta. Okay, so sine pi by 2 plus x is equals to cos x. This is 2 here. Okay, just look at this. Now I will be having 1 over cos x, and 1 over cos x is again sec x, which I've told you earlier. Therefore, the required answer is 1 over sec x. Okay, fine. Right. Now let's do another question. There is a question. 8th. Okay. Let there be a question like this: d by dx of sine inverse and x squared plus 5x. Okay, this is the question. Now, what is a parent function? Parent function here is sine inverse x. The parent function here is d by dx of sine inverse x. Okay, and the differentiation of sine inverse x is equals to 1 over under the root 1 minus x squared. This is the parent function, the differentiation of sine inverse x. Now here, x squared plus 5x, can assume it to be equals to x, not x. Assume it to be the x. And this is becoming the parent function sine inverse x. You will be having 1 over under root 1 minus x squared. And you are having 1 over under root 1 minus x squared plus 5x whole squared. This is 1 over under root 1 minus x squared plus 5x whole squared. Now, furthermore, you have to differentiate d by dx of x squared plus 5x. Now, see, understand. Since you have to differentiate here two things. First, you have to differentiate the outer function, which is sine inverse, and then you have to differentiate the angle part, which is x squared plus 5x. You are doing the same thing all the time. When you differentiate sine inverse, you are getting 1 over under root 1 minus x squared plus 5x whole power 2. Then you have to differentiate x squared plus 5x. Okay. Now I think we have done so many of the questions. Now you are not very panic. Why are we doing all these things? This is the method of chain rule. We have to do it. Now, this will come as it is. This is the same scene here. Okay. And here you have to differentiate x squared. You will be having 2x plus 5. So the answer will be, you have to write down this whole thing. This is under root 1 minus x squared plus 5x whole squared. And here, this is 2x plus 5. Okay. This is 5x. Okay. Don't get present. What is this? This is 5x. Oh. This is x squared plus 5. Okay. In this way, you can do the question. Going to the next question. Let's do another question. For example, you are having log 7 in the function. This is sine x plus x squared. Yeah, this is the question. You have to do it. You have to differentiate it. Now here, this is d by dx. In the case of log, what you must know about is that it can be rewritten in the form of log A base B as log A, and this is log. This is the method. I have to write it down again. Just wait. I'm uh, just wait for a minute. Okay. Now, this can be written as log 7. Yeah, this is log sine x plus x squared. And here this is log 7. These are the two parts in which we can separate the whole function. Log sine x plus x squared in the numerator part and log 7 in the denominator part. This is a sine of d by dx. Now the main thing is this is a constant number. It will go outside. So it will be like this, 1 over log 7 and d by dx of log sine x plus x squared. Okay. Understand? For example, if you are having 7 log x, if you have to differentiate, there is no need to differentiate 7. You have to differentiate simply log x, and it will give you 7 over x. Okay, in this way you can do it. Now, just wait. Now, this is sin x plus x squared d by dx. Now, here it will remain as it is 1 over log 7. Now, you have to differentiate in accordance to the log. And while differentiating with log, you know that the parent function is log x, then you will be having differentiation of log x as 1 over x. Now, here you will be having 1 over sin x plus x squared. Okay, this is all 1 over sin x plus x squared. Now, what you have to do? Third thing is remaining. You have to differentiate first the log, and then you have to differentiate the angle, the function. This. Now here you have to differentiate sin x over sin x plus x squared. Now here, what you will be having? You will be having 1 over log 7, then sin x plus x squared, the bracket. And when you differentiate sin x plus x squared, which is here, you will be having cos x plus 2x. What it means? It means that the real answer, the last answer with you is cos x plus 2x whole over log 7. And this is sin x plus x squared. This is the required answer for you. Okay, clear? Let's do one more question. You are having sine log sine x. Okay, now the outermost number is sine. The outermost function is sine. We have to differentiate with respect to, we have to differentiate with sine first. Now we know the parent function is sine x, and we know the differentiation is cos x. I'm not writing the formulas again on the right hand side. I'm just putting it there. Okay. Now here, what it will be? It will give you cos log sine x. Okay. Now I have differentiated sine x. Now the next part is about the log sine x. Now I have to differentiate log sine x. This will give me d by dx of log sine x. There is a power map. Okay. Now we are on the question number 10th. Okay. Now the question number 10 says, you are having a d by dx of sine log sine x. Okay. This is the question. You are having sine log sine x. Clear? What is the sine log sine x? Okay. This is log log. Now, what we are having? I was just explaining you. You have to differentiate 3 types. The first is sine outermost, then is log, and then you have to differentiate the what we call as sine x in the internal part. Now, while we differentiate this sine x, we are having the function as the parent function as sine x, and if we differentiate the sine x, we will be having cos x. Now it will be like this: cos log sin x. This is the result. If we differentiate sin x, we will be having cos log sin x. Next, after this, I have to differentiate this. This is the d by dx of log sin x. Now I have to differentiate log sin x. Now, on differentiating this, what we will be having here is that this is cos log sin x, okay? And d by dx of log sin x, here this is log sin x. You will be having 1 over sin x, okay? And as well, if you go with d by dx of sin x, like this. Now here, the answer will be cos log sin x. Denominator, you are having sin x. And here, if you differentiate it, you will be having cos x. Now, while simplifying, you can do one more thing. You can take this out. And it will be like this. Cos log sin x cot x. Because you know, cos theta over sin theta is equals to cot theta. Now, next question. You are having a question like this. This is tan inverse e raised to power sin x. Okay, this is the question. Now, here in this question, if you go for the differentiating part, what you will be having? You will be having first you have to differentiate this tan x inverse x. And we know parent function is d by dx of tan inverse x. Then its differentiation will be 1 over 1 plus x squared. Okay, clear? The differentiation of arctan is equals to 1 over 1 plus x squared. Very simple. Now, here, if you assume this to be x, then here it will give you 1 over 1 plus e raised to power sin x. And this is whole square. As well, if you differentiate, now this is the tan inverse x. Now, if you go for tan inverse x, but here, this is not actually the x, it is e raised to power sin x. Therefore, what you have to do here is, you have to now differentiate d by dx of e raised to power sin x. Okay, now this whole thing will be here. Okay, I'm not writing it just again and again, I will be writing it the last. And here, if you are having a d by dx of e raised to power x, you are having e raised to power x, which is a parent function e power x. But here, you are having e power sin x, it will give you e raised to power sin x. Then, what do you have to do? You have to differentiate this sin x also. Sorry. Now you have to differentiate this sin x. Now, the required answer will be 1 over 1 plus e raised to power sin x, the whole square, times e raised to power sin x, times cos x. This is the required answer if you differentiate this whole. Okay. Now, let's do another question. If you are having a question like this, cos, and this is log cos inverse x. Okay. Clear? You are having d by dx of cos log cos inverse x. You have to differentiate 3 terms. First, you have to differentiate the outermost term, which is cos. Then you differentiate the in the middle term, which is log. And in the last, which you have to differentiate, this is cos inverse x. So if you differentiate the first cos, you will be having, we know that if the parent function is cos x, it will give you, on differentiating, you will be having minus sin x. So therefore, here it will be minus the sine log cos inverse x. This is the differentiation of cos, which is minus sin x. Now, what you have to do is, you have to differentiate the second term, which is the middle term, which is the log. You have to write down d by dx of log, and this is cos inverse x. If the parent function is log x and you have to differentiate it, you will be having 1 over x. What it means? It simply means that here you are having sine log cos inverse x. And in the denominator, you will be having 1 over cos inverse x. Okay? In the numerator, you are having minus sine log r cos x over r cos x. Okay? Now, what next? You have differentiate the first cos, you differentiate the middle log. Now you have to differentiate this remaining cos inverse x. Now here, this is d by dx of cos r cos x. Now, we know the differentiation of r cos x is equals to how much? I'm just writing it here. Okay. Now the answer will be minus sine log r cos x over arc cos x. And in the multiplication, you are having arc cos x. It will be equals to minus 1 over this is what? Under root 1 minus x squared. Okay, this minus and minus will cancel out each other, and you will be having the remaining thing as your required answer. I'm just taking it to the upper part so that it is to be clear, visible to you. Now here, see this. Okay, now here this is the answer for this question is sine log cos inverse x over arc cos x times under root 1 minus x squared. Clear? Now, let's go on to the next question. This is question 14th. Now, yeah, I'm doing one more thing. Another thing is there. Now, here you are having the function inside the function. Now, here we are applying the product rule and the chain rule, both in one class. For example, if you are having d by dx of e raised to power 3x and times you are having cos 5x. This is the question. You are having d by dx of e raised to power 3x cos 5x. Now what you will do? The thing here is you have to first apply the product rule here. Here in this case, e raised to power 3x is acting as a fx, whereas cos 5x is expecting as a gx. Now, in the earlier classes, I've already told you about the product rule. You can just go and watch what the actual product rule is here. And in case you are facing any difficulty not able to the questions, you can simply put a comment in the comment box, and I will be there to help you. Okay. Now here you are having d by dx of e raised to power 3x and cos 5x. Now here, on applying this, so there is something interesting. I will just write down the formula for the product rule first, so that it will help you. Now here, if you are having a function like this is fx times gx. You have to just write it like gx will come as it is. Then you have to differentiate the fx first function. Then fx will remain as it is, and you have to differentiate the second function. Okay, and this way you can write down the fx and gx. Now, here in this part, you are having gx. This is 5 cos 5x. It will remain as it is. Okay, now here this is d by dx of e raised to power 3x. Furthermore, you are having e raised to power 3x here, and this is d by dx of cos 5x. Okay. Now, what else you can do here? You can just go with this. This is cos 5x. And if you differentiate e power 3x, the parent function is ex. Therefore, it will give you e raised to power x form. This is e raised to power 3x. But now this is not x, this is 3x. You have to differentiate the 3x also. It will give you 3. I'm doing it here. Just see it. I'm saying that you are having d by dx of e raised to power 3x. The parent function is ex, and if you differentiate e power x, you will be having e raised to power x. Here it means e raised to power 3x. But actually it is not x, it is 3x. What it means that you have to differentiate the 3x also. And if you are differentiating 3x, you will be having e raised to power 3x times 3. Therefore, you will be having 3 e raised to power 3x. Okay, and this way you are getting it. Clear? Now, this is the second part, which is e raised to power 3x times d by dx of cos 5x. And you know very well the differentiation of cos x, the parent function is cos x, differentiation of cos x is minus sin x. Now here it will become minus sin 5x. But here, this is not x, this is 5x. You have to differentiate the 5x. Same as you have done here, you have to differentiate the 5x also, and you will be having the 5. Now, just write it 5. Now, in the both the things, you are having 3 power x common. You have to write it out at as e power 3x. In the bracket, you will be having the first part, 3 cos 5x. Okay, that's 3 cos 5x. And here this is plus, and here this is minus. It will become minus multiplication. It will come here in the middle, and you will be having 5 sine 5x. Okay, in this way you can write it down. Okay, in this way you can write it down. Then your answer will be e raised to power 3x, 3 cos 5x minus 5 sine 5x. Okay, nice. Next question. For example, let's do one more question of the type this. For example, you have to differentiate d by dx of log sine x, and another one is just interesting. I got it now. This is you are having 2 raised to power cos x. Okay, these are the two functions here. This is one is log sine x, another one is 2 raised to power cos x. This is the first function fx, and this is the second function gx. First thing is you have to apply the formula for product rule, which I have told you in the previous question number 13. And now, second thing is you have to apply this. Now, what will happen? What will happen here is that you have to put the gx part as it is, which is a 2 power cos x. And you have to differentiate d by dx of log sine x. Plus, log sine x will remain as it is, and there will be d by dx of 2 raised to power cos x. Okay. Now what? Now if I go with this, and if I differentiate this, this will give me 2 raised to power cos x. And if I differentiate this, this is log sine x. And in the case of the log sine x, if I take it as log x, parent function, it will give you 1 over x on differentiating. And what it means that here I will be having 1 over sine x. Now the sine x, I can put it here in the denominator. And furthermore, one more thing is there, that I have to differentiate sine x, because it is not x, it is sine x. Same thing, if I would here in this case, this is log sine x. And d by dx of 2 raised to power cos x, we know that d by dx of a raised to power x, this is a parent function. I will be having a raised to power x, and this is log a. Right? Now here we are having 2 raised to power x cos x, and it is just same as the t by dx of a raised to power x. We will be having 2 raised to power cos x, and this is log 2. But in actual, the cos x is not x. Then what we have to do? We have to differentiate this cos x again. Now, if we go to differentiate this cos x, we will be having d by dx of cos x. Now, the next part, what I will be having, the first thing which I can take a common as, I can take common as 2 raised to power cos x here, and 2 raised to power cos x here. I can take this common out. I can take this out. Here this is 2 cos x, and here this is sine x, and this is d by dx of sine x. D by dx of sine x is cos x, and here this is sine x. I can write it like this, plus log sine x. This is log 2, log sine x, log 2. And if you differentiate cos x, you will be having minus sine x. Okay. And this way you can write it as your answer. Furthermore, one more thing you can write it. The next step, you can remove the sign from here, and then plus will cancel out. The sign will come here in the middle. Okay. Nice. Let's do one more question. I'm doing question number 15th. If I suppose this is a product rule, and if I go with the question rule, what I can do here? Okay, what I can do here? You are having a question like this: d by dx of a raised to power 10x, and in the denominator, you are having what you are having. Let's say you are having x raised to power 12. You are having x raised to power 12. What you have to do is you are here having a product. Oh, sorry, question. And the question you know the formula very well. The formula says you are having a question to d by dx of just wait, and first write down here d by dx. This is old question. Now what I was saying that you are having d by dx of product rule. This is d by dx of fx over gx. Now here the same thing which we had to use in the case of the question rule, product rule. Now here you can see that you have to put gx as it is, and then you have to differentiate the fx, the numerator part, and you have to put a sign of minus, then fx, and then d by dx of gx. Okay, clear? Now here what else you can do? You can put here gx whole square is there. This is gx d by dx of fx minus fx times d by dx of gx over gx whole square. Now what else you can do here is, this is, how much is gx? Gx is x power 12. This is x power 12. And here d by dx of fx. This is d by dx of fx. This is d by dx of e power 10x. Okay. Now minus. This is a power 10x. Okay, fx. And this is d by dx of gx. This is x power 12. And in the denominator is x power 12 whole square. Okay. In this way, you could write down first. What it means, first you have to apply the question. Then what else you can do? You can say it like this. This is x power 12. This is a power 10x. We know when we have done in the previous question that a power x differentiation of a raised to power x is equals to a raised to power x log 2 log a. Now here, this will remain as it is. This is give you a raised to power 10x. And this is log a. Whereas this is the x, that 10x is not equals to x. Therefore, we have to differentiate the 10x also. Now, if we differentiate this 10x, I have to write this down. This is d by dx of 10x. And minus a raised to power 10x. And this is d by dx of x raised to power 12. And this x raised to power 12 is how much? This will give you simply 12x raised to power 11. In the denominator, you will be having x raised to power 24. Okay? Now just wait. I have to erase the question, the parts just about this. Okay. Now, what I can say here, I can take, first of all, I can take something common, and I can take x raised to power 11 common. I can take a raised to power 10x common. Okay. Now here in this case, I will be left with x, and this whole thing log a. And if I differentiate 10x, I will be having sec square x. Okay. Now there's a minus sign, and a power 10x and x11 goes outside, they remain 12. In the denominator, I will be having x raised to power 24. Okay. And if I bring this down, x power 11 down, and cancel out this 24, I will be left with 13. Therefore, your answer will be a raised to power 10x bracket x log a sec square x minus 12 over x raised to power 13. Okay, over x raised to power 13. Just wait. Okay, now do another question. Let's say you are having a question like this, which are having both these things, product rule as well as the question. Okay, and this is something. Next question. You are having a question like this: d by dx of e power x cot root x, and in the denominator you are having make it simple. You are having let's say sine x, okay, or sine x cube. Okay, now there are two things which you have to think about. There are two things. The first thing is there is a product rule. Second thing is there is question rule, and there is a chain rule. All the three things are there. Okay, now here this is assumed to be fx, this is assumed to be gx. I'm not writing the formula again here in this question. I have written in the previous question. I'm just solving it out. Now here what the method is. First you have to write down this g cube gx, which is sine x cube, and you have to differentiate e power x. This is cot root x. Furthermore, you have to put a sign of negative. You will be having e raised to power cot root x, and now there is d by dx of sine x cube. Okay, now here I have to put sine x cube whole square. E raised to power x cot root x d by dx of sine x cube is there. In the denominator I have to put sine x cube whole square. Now here I have to differentiate the first part. This is sine x cube. In this part here, which I have to differentiate, I have to write it. This is now here what you do. This is a case where I have to just first I have done the question rule. Now here in this part I have to apply the product. Now in the product rule, what I have to say, I have to put cot root x as it is, and I have to differentiate e power x. Then I have to put a positive sign. Then e power x as it is, and I have to differentiate cot x. Minus e raised to power x cot root x, and then there is sine x cube. Sine x cube gives me cos x cube, and if I differentiate x cube, okay, I just write it down, d by dx of x cube. In the denominator will go by sine x cube whole square. I'm not writing it. I will write it in the last. Okay. Now this differentiate. Now I'm having sine x cube. In the bracket, I will be having cot root x. D by dx of ex will give me e power x plus e raised to power x. Now, how much is the value of cot root x? Cot x, differentiation of cot x is equals to minus cosec square x. It means minus cosec square root x. Okay, but this is not sufficient because this is not cot x, this is cot root x. What it means that I have to differentiate root x also. This root x, I'm talking about this root x, which I put in circle. Okay, now if I go outside this bracket, I will be having minus e raised to power x cot root x cos x cube, and this is 3x square if I differentiate x cube. I am very much clear to you. Okay, fine. Now the next thing and the last thing is, if I go with this, I will be having sine x cube in the bracket cot root x times e power x plus e power x. Now this plus minus will give you the sign of minus. Okay, now here this is cosec. Okay, this is cosec root x. Now here this will give you minus e raised to power x cosec the square root x. And non differentiating this under root x, we know it will give you 1 over 2 root x. Now minus e raised to power x cot root x cos x cube. This is 3x square, and whole over you are having the same thing, which is this which is sine square x cubed. Okay, this is the part which we are having. Now, what else you can do here? What else you can do here? I'm just taking this my pick on the upper part. Now you can easily watch this. Now here what happens? Now you have to solve this. You have to simplify this. The first thing what you can do here is you can take something common, and the only thing which I can take common is uh, e raised to power x, because it is coming in all the three steps. Here, this is here, here, and here. You can take e power x as cot root x. You can't take because in the middle cos x square x is coming. You can't take under root x common. You can't take any other thing common. You can simply do this thing. You can take e power x common and everything else inside the bracket. You can further take 2 root x, this one, as the LCM, and you can do the solution simplification. Okay, as you can, if you want, you can leave it as you want. Okay, this is a question number 16, in which both the thing happens with you. You can do the, you have to do the product rule, you have to do the question rule at first, then you have to do with the product rule, and then lastly, you have to do the chain rule also. Okay, now just proceed with another question. Okay. This is the formula for cos 2 theta. Cos 2 theta is equals to 2 cos square theta minus 1. Now, if I take this 1 here, I will be having 1 plus cos 2 theta is equals to 2 cos square theta. Fine. But here in the question, I'm asking, I am requiring cos theta, not cos 2 theta. What else we can do is, I can simply do a simple solution that I will do the half of the angle. And if I am saying the half of the angle I have to do, it means I have to do the half angle in each and every place where there is theta with this angle. Now, by doing all these things, the 2 and 2 will cancel. I will be having 1 plus cos theta is equals to 2 cos square theta over 2. Furthermore, there is another formula for cos 2 theta, which says we're having cos 2 theta is equals to 1 minus 2 sine square theta. Okay. Now I bring this 2 sine square theta on the left hand side. I will be having 2 sine square theta is equals to 1 minus cos 2 theta. Again, I don't require cos 2 theta, I require cos theta. For doing this, I have to divide only the angle part. Mind it, only the angle part by 2. Then I will be having 2 sine square theta by 2 is equals to 1 minus cos theta. Now I'm just going here and just put this down, d by dx of log. This is under root. Now, how much is 1 minus cos theta? It is 2 sine square theta by 2. That means here it is 2 sine square x by 2. Denominator is 2 cos square x by 2. 2 and 2 will cancel out. This is log under root sine square x by 2 or sine x by 2 over cos x by 2. This is whole square. And this whole square will cancel out by this root. And what else I'm having? This is log under root 10 x by 2. And this, okay, this is cancel out. No, this is not there. This is cancel out. This is log 10x by 2. This is log 10x by 2. I have to differentiate d by dx of log 10x by 2. And what I have to do here? What I have to do here? I have to simply put some chain rule here. Okay, this is log. Okay, now I have to put this chain rule. Now this is log 10x by 2. We know that the differentiation of log x, parent function is log x, its differentiation is 1 over x. This is 1 over 10 x over 2. And then furthermore, what I have to do is I have to differentiate 10 x by 2. This is d by dx of 10 x over 2. And I will be having 1 over 10 x by 2 times sec square x by 2, because we know that the differentiation of 10x is sec square x. Now this is sec square x by 2. Furthermore, I have to differentiate d by dx of x over. Okay. First, log, then 10, then x by 2. Now this 10, I can write it in the form of sine theta over cos theta, then cos will go into the upper side, it will give you cos x by 2 over sine x by 2, and we know that the sec square x by 2 can be written as 1 over cos square x by 2. This is cos square x over 2, and for x by 2, I will be having 1 over 2 on differentiation of x by 2. Now this cos x by 2 will cancel this out, and the denominator will be having 2 sine theta cos theta. It will give me what? It will give me the formula which I have told you earlier. This is 2 sine theta cos theta is equals to sine 2 theta. Now here it will give you sine 2, and theta is how much? X over 2. This 2 will get cancelled. Now, how much is the answer is? The answer will be here, will be here, will be, answer will be 1 over sine x by 2. And sorry, 1 over sine x, 2 will get cancelled. Now, 1 over sine x is equals to cosec x. This is your required answer. This is the answer of d by dx of log under root 1 minus cos x over 1 plus cos x is equals to cosec x. Okay, let's do one more question. One more question we can do. Let's take. This is d by dx of this we can take what log tan inverse x raised to power 5. Okay, clear? Now here again, what you have to do, you have to apply the chain rule. First, you have to differentiate in accordance to the log. The parent function is log x. We know that the differentiation of log x is equals to 1 over x. What it means that here you will be having 1 over tan inverse x raised to power 5. 1 over tan inverse x raised to power 5. Now, next thing is I have to differentiate d by dx of tan inverse x power 5. First, I have to differentiate tan inverse log tan inverse x raised to power 5. Then there comes 1 over tan inverse x power 5. Then d by dx of tan inverse x power 5 is there. Now, what we know about the tan inverse x differentiation? We know that arc tan x is equals to 1 over 1 plus x square. In the earlier questions, we have done it. Now here, it will give me 1 is equals to 1 over arc tan x raised to power 5. And here, this is tan inverse x power 5. It will give you 1 over 1 plus x raised to power 5 whole square. Because d by dx of tan inverse x is equals to 1 over 1 plus x square. Okay, now this is the thing. Now in the next part, you are having x raised to power 5. What it means? It means that you have to differentiate x power 5 now. Okay, now these are the d by dx of x raised to power 5. And on differentiation, what you will be having is, this is 1 over tan inverse x power 5. This is 1 over 1 plus x raised to power 10. And this is 5x raised to power 4. This is the required answer. You can put it in the one place. You can say this 5x raised to power 4 whole over tan inverse x raised to power 5 times 1 plus x raised to power 10. So this is the required answer of d by dx of log tan inverse x raised to power 5. I think, and I'm very much clear to you that you are all able to understand these questions which I've done in this class. And in any case, if you are facing any of the difficulties in the understanding of the concept of product rule, quotient rule, and the chain rule, the differentiation, you can contact me. You can put your comment, you can post your comment, and I will look to them and I will try my level best to solve them for you again. And we'll try to explain you in a much better way. Okay. Thanks for watching and viewing these exercises, these questions. And thanks a lot.